Welcome to our lesson on standard deviation and variance. These important statistical measures help us understand how spread out our data is from the mean. Let's start with an intuitive understanding of what these concepts mean. Standard deviation and variance both measure how spread out our data points are from the mean or average. Variance represents the average of squared differences from the mean, while standard deviation is simply the square root of the variance, giving us a measure in the same units as our original data. Let's work through a simple example to calculate the variance and standard deviation. Imagine we have 5 test scores: 70, 80, 90, 60, and 100. First, we calculate the mean, which is the sum of all values divided by the number of values. In this case, the mean equals 400 divided by 5, which equals 80. Next, we calculate how much each data point deviates from the mean. For 70, the deviation is 70 minus 80, which equals negative 10. For 80, it's 0. For 90, it's positive 10. For 60, it's negative 20. And for 100, it's positive 20. Now, we need to square each deviation. Squaring the deviations ensures all values are positive and gives more weight to points farther from the mean. Next, we sum the squared deviations. 100 plus 0 plus 100 plus 400 equals 1,000. To get the variance, we divide this sum by the number of values, which is 5. So, the variance equals 1,000 divided by 5, which equals 200. Finally, we calculate the standard deviation by taking the square root of the variance. Standard deviation equals the square root of 200, which is approximately 14.14. The standard deviation value is in the same units as our original data, test scores, which is one reason it's often more useful than variance in practical applications. Let's visualize what the standard deviation means for our data set. Here's a histogram of our test scores. The red line represents our mean of 80. The green lines show one standard deviation, 14.14, above and below the mean, which means approximately 68% of the data in a normal distribution would fall between these lines. Let's compare different data sets to better understand variance and standard deviation. Here are 3 data sets, all with the same mean of 50, but with different spreads. Data set 1 has values close to the mean, resulting in a small standard deviation of 5. Data set 2 has more spread, with a standard deviation of 15. Data set 3 has the largest spread, with a standard deviation of 30. Notice that a higher standard deviation indicates that data points are, on average, farther from the mean. Standard deviation and variance are used in many real-world applications. In manufacturing, they help control product quality by measuring consistency. In finance, standard deviation is used to measure risk and volatility in investments. In weather forecasting, it helps predict the range of likely temperatures. In education, it shows how spread out test scores are. Let's summarize what we've learned. Variance measures the average squared distance from the mean. The formula is sigma squared equals the sum of x minus mu squared divided by n. Standard deviation is the square root of variance and measures the average distance of data points from the mean. The formula is sigma equals the square root of the sum of x minus mu squared divided by n. Remember, a higher standard deviation means more spread out data, while a lower standard deviation indicates data points clustered closely around the mean. Thank you for watching this tutorial on standard deviation and variance. These statistical measures are essential tools for analyzing data dispersion and making informed decisions based on data variability.